Welcome to the fourth episode of CANversations, where we will talk about what it is that makes the CAN technology unique. But first, let us introduce today's new guest in CANversations, Wolfgang Mathis. So, who are you, Wolfgang?
Yes, good morning. My name is Wolfgang Mathis. I'm currently Chief Technology Officer in Neodrill. I've joined the company almost 12 years ago, so I've had quite a journey within Neodrill. I had the pleasure to join the company when it was very small, so I joined as the first technical employee beside the founder, Harald Strand. And due to this constellation, in the beginning being only two people in the company, it has been very interesting, very widespread job. So I've been exposed to all and everything that is going on in a small business. So from marketing to sales, develop the technical aspects of the product, develop it further, bring it to the market.
I'm curious. What made you jump on this chance, only two of you, and such a complex or product?
As many things in life, it was a coincidence. I was looking for a new challenge. I had contact with a headhunter, and he introduced me to a few different companies. One of them was Neodrill. At the first glance, I thought, this doesn't look like my profile. But after talking to Harald and thinking it over, the more I saw relevance to what I did and what I could contribute. And what was very interesting, of course, I've worked in smaller companies where I had a certain influence, where I could really help bringing products further. And so when presented or thinking about this opportunity long enough, I decided to join. And one of the main aspects maybe was Harald and Arne, who was chairman of the board, very experienced persons. So on my side, the gain was to learn from very experienced people, willing to share their knowledge. So that was an opportunity that I couldn't say no in the end. Now 12 years later, I think I have done my share, and hopefully will continue to do so. It's, as I said, it's been a very, very interesting journey in many, many aspects, not only technically, but financially, IP, patents, defending patents in front of a judge, and all that comes with being in a small company developing technology.
So it's been a really, really good learning.
It's been a good learning experience for me, building me as a professional and contributing to a process that has been growing from one person, two persons to 20 plus now, increasing the revenue, improving the technology, widening our customer base. It's been very interesting and challenging, and at the same time very rewarding.
Has it required a lot of patience, would you say?
Yes. The oil business is sometimes seen as being at the forefront of technology, but at the same time it's very, very hard to introduce new technology, getting it accepted. So
So what is it about the CAN then that is new and unique compared to similar technology?
Well, the CAN itself is a very simple construction. It's basically an upside-down bucket, so it's closed at the top and open at the bottom. And Neodrill uses that suction anchor and integrates the conductor, which is the first well section, into the conductor before it goes offshore. So that means that we are doing the first construction step of the well without a drilling rig. Rig rates are very high, very costly. And that has been really the base thought of Harald Strand. The original patent is exactly about that, how to establish the conductor on the seabed without using a drilling rig. So these cost savings on one hand, but the important thing is that technology-wise, it's also better and more controlled than installing a conductor conventionally. So by installing the CAN ductor beforehand by a vessel, you have verified the load capacity, you have verified the inclination. That's all measures that are important for when the rig arrives. So you know that your conductor is according to spec. If anything should go wrong during the installation, not that it has happened yet, but if anything should go wrong, rig arrival is still weeks away, so you can react and fix before the rig arrives.
And for me to understand, usually you do this on the seabed. But
yes.
You do it, CAN technologies before you put it in the sea.
The CAN itself is the carrier for the conductor, and that is installed on the seabed. That is correct. So a suction anchor works by applying a differential pressure. So you suck out water in order to make it penetrate into the seabed. So the technology wouldn't work on land. But in 50 meters plus water depth, there is normally no issue to install them. So yes, the conductor is installed before the rig arrives, so that takes away many uncertainties for the initiation of the well.
But usually it's installed when the rig, together with the rig. So this is unique with the CAN technology. It's installed before.
Yes, usually the conductor is either drilled and cemented or jetted by the rig. But we do this before the rig arrives. So when the rig arrives, you already have done the first section of your hole, and you can go straight to the next section, which has the aforementioned commercial or economic benefits as well as technical benefits. But it also has a number of environmental and safety benefits. Thinking of that a rig has much more emissions than a vessel. And also on the rig you have to handle quite big pipes. So one pipe section that is 10 meters long, 1 meter in diameter, is easily 10 to 15 tons of weight. So they need to be handled on the rig floor by people with winches and all that, but still they need to be connected and lifted in. And it has happened before that the conductor joint has come loose and fell on the rig floor and has caused some damage, potentially injury. So that those are very clear benefits of the CAN technology overall.
That sounds very good. And Vidar, just letting everyone know that there's the three of us here today, and we talked about, because you said environmental benefits, we've already talked about that in another podcast.
Absolutely. So I think Wolfgang is spot on when it comes to the technology and, and the differentiating here. So glad we had Wolfgang with us today to could explain that very, very clearly. So and the environmental piece of it, absolutely. So we touched upon that in some previous episode, but that's really one of the things that we see that is becoming a growing attention from our users that, yeah, we would actually like to see and have this green stamp on our project, showing that we are actually taking actions to reduce the CO2 emissions, to reduce spill to sea, and so on. Yeah.
And that's one of the things that makes this technology unique as well, that is more environmentally friendly than other similar technologies. Is that right?
Yes, so I can also maybe say that in the beginning, the CAN technology, it's, as I said, it's difficult to get new technologies accepted in any industry, particularly the oil industry, because potential consequences are very damaging and costly. So in the beginning, it was more a problem solver. So very special problems, for example, very soft seabed, where the conductor stability was expected to be an issue, where the CAN was adapted first. But more and more, the more we developed the technology, integrating the conductor directly into the CAN, the value case improved, the CO2 emissions were reduced. So with all those benefits, it's becoming increasingly more difficult for new adapters to say no.
Exactly. And was this a planned benefit, or did some of the benefits just happen as you developed the technology?
Most of the things let's call it, they were planned, or we had ideas that we wanted to get out and get tried. The first adapter again to have the conductor directly integrated onshore. That was a very special requirement of one of our customers with a very shallow reservoir. So if you're thinking of a reservoir being only 240 meters below the seabed, and you need to enter the reservoir horizontally, and that means basically that you have to drill a 90-degree bend, then using a conventional conductor that is usually set to 50, 60, 70 meters below mudline, it becomes, or it is very difficult to already bend a conductor pipe, which is a pipe with 36-inch or 914 millimeters of diameter, so almost a meter, with wall thicknesses from 25 millimeters to 40 millimeters. So it's impossible to bend that pipe. And then the clear benefit of the CAN conductor in this case is to give a foundation to that conductor with only 10 meters below mudline. So instead of having 60, 70 meters of vertical hole in the beginning, you can reduce that to 10 meters. And in that case, it was an enabling technology to drill that reservoir horizontally. And also the reason why the customer dared to do this first off. From there on, it was much easier for us because we had a reference case. It had been done before, and it's much easier to find the second user of any new way of doing things. And from there on, the CAN conductor has basically replaced the CAN basic, which is the same suction anchor without the conductor integrated. But we still use it sometimes in very special cases, but it's more the oddball these days than standard. So the CAN conductor has become our workhorse, where we have the most projects around it.
It's very interesting to hear that the development also happens together with your customers, that they have a need and you're trying to adapt to that. Is that
Yes,
correct to say?
yes, of course. Many of our adaptations or developments, they are customer driven or customer supported. A customer needs a special variation, and we are small companies. That means we are agile. We can react to wishes or do things differently. I think that's one of the big benefits of being a small company. The bigger the company grows, the more set things are, the more difficult it is to implement changes, and that's also one of the reasons why the job is so interesting.
Yeah, because you're specialized, but you still have to do many different things, and you can turn around quickly to adapt to customers' needs.
Yes.
Absolutely. No, I totally agree with you there, Wolfgang. So thinking of it's quite a sort of basic technology, but when you look at all the applications that we are actually seeing for this technology, it's quite amazing. And me, just sort of a newbie here compared to Wolfgang, but still seeing all the opportunities that lie with this technology is quite amazing, which we're not going to touch upon in this meeting, in this session, but potentially in programs later on. So, but as a differentiating technology, absolutely, I think the industry is sort of becoming more and more aware of that this is not only an alternative or a sort of a special problem solver. It's actually becoming the best practice for top pole developments. And not only here in Norway, but we see a growing interest internationally. And, the deeper waters maybe even more attractive solution, really. So,
and you've, as I understood, you've patented this solution. So when this is becoming the best practice, then companies need to come to Neodrill to have this exact solution.
Exactly.
Yeah.
Exactly. So, which of course we're here to help, and we're a company that want the customers to be successful, and but still, it's not like we have a monopoly, because if we not behave, make sure that we are competitive, customers can easily go back to the old fashioned way.
Yeah.
Yeah. So it's not like we are a monopoly, as I said. We're definitely in here with competition. But if you look at the benefits that we provide and the total package, the value case becomes very attractive. That's what we see and experience from our customers.
Because they save money, they save time, it's more environmentally friendly.
And they take away a lot of risks, both safety risk, but also operational risk. But these kind of things is very difficult to sort of put in front of the customer, because they don't cost anything until the shit hits the fan. Then it's difficult. Then the money starts flowing, and they could easily say, "Oh, we should have had."
Yeah.
So, but we are trying to be upfront there and trying to convince. And as I say, it becomes, with the experience we have, gradually easier for customers to see that, yes, this is really the best practice.
Do you have an example of a customer where they used old technology and then now they use your technology? And
I think a prime example would be an exploration well that has been struggling, or they have been struggling with the soil conditions. Oh no, sorry, not an exploration well, a production well actually. The customer had tried to drill the well twice, and in both instances, the conductor became unstable after having the BOP on. That's when let's call it big loads come. A BOP is a stack of valves that weigh anything between 250 and 400 tons that is set on the wellhead. And in addition, it's connected with a riser to the drill rig, meaning that there are tension loads on that riser, and this BOP is rocking back and forth. So the tremendous bending moments put onto the conductor. And in both cases, the conductor became loose and they had to stop drilling and respud, meaning that they have to do another attempt. Now, with the rig day being around about 10 million Norwegian kroner per day, and you are a couple of weeks into drilling your well, you can accumulate the costs. We then talked to the customer. They approached us. It was challenging seabed conditions, alternating clay and sand, which is not straightforward. But with doing your homework, doing good soil investigation, we came to a design and installed it. And the well, using the CAN ductor technology, has been successfully drilled, and the well is in production. So what? Thinking of 2 attempts with at least 30 rig days in each attempt, that's 60 rig days times 10 million NOK. You can imagine the sunk cost.
It's a huge cost.
On that one well.
Yeah. And how many days do you spend?
No, the CAN ductor installation, that's typically 24 hours, we say, and that's conservative. 24 hours on location, so plus mobilization, transit out to the field, transit back. So a couple of vessel days, which typically accumulates to maybe 1 rig day.
And here they spent 30 rig days.
Yeah, but that's an incident, right?
Yeah.
So that's an incident. In normal circumstances, you would use maybe 2 to 3 rig days to establish the conductor. So the net saving would be 1 to 2 rig days or 2 to 3 rig days, depending on the overall operation. But there is a saving even if nothing goes wrong.
Yeah, there's still a saving if we're talking 10 million.
Yeah.
Each rig day. So. Wow.
But if something goes wrong, then the cost accumulation is just astronomical.
Yes, but what I understand from what you're saying now is that you can design each CAN uniquely for the rig that it's supposed to.
Yes, the CAN is, at least here in Norway and the UK, in North Sea soil conditions, we've standardized on 6 meters diameter. And then the CAN height, that depends on how soft the soil is and how big the loads are. So the stronger the soil and the lower the loads, the shorter the CAN. The higher the loads, the softer the soil. The higher the CAN needs to be. So for each and every application, we do a geotechnical assessment where all the input parameters are assessed and go into geotechnical engineering, and then you result with a minimum height that is required to achieve the load capacity that is necessary for a particular well. And I think also from that, let's call it geotechnical engineering, is dealing with soil. Structural analysis, when dealing with steel. Steel is a material that is much more defined and can be tested much better than soil. So there are uncertainties or higher uncertainties in soil. That's why for steel you have, example, the yield strength. You have one parameter for a steel, but for soil you have always a set of parameters, which means you have a low end, that's the lowest you can expect, and you have a high end, that's the highest you can expect. And in this engineering, you always take the lowest parameters to do the load capacity assessment. So you're sure you have the minimum load capacity. You always use the high-end estimates in order to calculate the installability. So that means what type of under pressure that is needed. If we would be too aggressive in that respect, then we would ignore the high end and we would try to apply under pressure. You can think of that as a Coke can. If you squeeze it too hard, it collapses. So we have to be very particular in this engineering, because of course we as Neodrill, we don't want our technology to fail in either respect. We don't want to have a can that's moving when the rig is connected. But we don't want to have a failed installation either by collapsing the can and just making a...
And this takes us to the next podcast, actually, where we will talk about
the installation. Yeah, absolutely.
The risks and the installation and what precautions you take. So.
But maybe, Wolfgang, you can talk about, we're obviously dependent on some input data here. So maybe you can talk about what kind of data, or how do we gain that normally in order to make sure that we design the cans specifically for that location?
It gets very technical, but yes, there is...
Bring it overarching.
Yes. No, there is one test that gives us very valuable information, and that's called a cone penetration test. And that's basically a spear that is pushed into the seabed and measures the tip resistance and the friction along the rod that is pushed in. So that gives us a parameter that is called the shear strength of the material for clay type formations. And that is really the minimum that we need in order to do the geotechnical engineering. There is additional parameters that can help and improve the data. So the more data you get, the better the design is. Not meaning that being more risky or less risky. That just means if you have more data, that you can have to be less conservative on the low end and also on the high end parameters, so that those two come closer together, and you can optimize the can height better than with less data.
And just I need to visualize this. How do you get that data? Do you use like a U-boat? How do you get down to the seabed to get the data?
That's something done by the operating company. It's very typical that you do a geotechnical site investigation on the location, and that is essentially it's a 10 to 20 ton clump weight that you lift onto the seabed. Which is supplied with energy, either electrical or hydraulical. And then that rod is part of that clump weight. And there is a simple mechanism that pushes that rod into the seabed while measuring the resistance at the tip and the overall resistance. But it's not done by Neodrill. That is done by different providers, geotechnical providers, that then also do the analysis and conclude with the geotechnical parameters that are input into our design.
So they specialize in providing this information to companies. Yeah. Interesting.
Very good.
Yeah.
So I can maybe just say a few words about technology and technology development. There are, let's call it spin-offs or uses that we initially hadn't thought about, but another example is what we call can parking. That is a can with a wellhead that is put on the seabed, and you can use as a parking location. So that's beneficial because if you have to do some work on a well that is already in production or that is already injecting. And you need to remove the BOP. You need to remove the Christmas tree in order to do workover, either do a sidetrack or do any maintenance on what's in the well. The normal procedure nowadays is to pull the Christmas tree to surface. that both takes time and triggers a very stringent maintenance regime. So once you break the water surface with both the BOP and the Christmas tree, there is much more maintenance that needs to be done than when you if you keep both of them at the seabed.
And Christmas tree? It's
Christmas,
not a decorated tree, I
it's
guess.
the right time of the year. Yes,
Yeah.
I agree. A Christmas tree is a big lump of steel with a lot of valves that steer the production or injection. So at the seabed, you have a wellhead, and then on top of that wellhead, you have a Christmas tree that basically allows you to steer the well. So you can open or close the production. You can control what's called annulus A, annulus B. You can do inhibitor injection. So it's
And the name? Why a Christmas tree?
because in the old days it was one valve on top of the other with almost like branches coming out. So if you look at a very old Christmas tree from a land well, you will see that it looks like poor man's Christmas tree. Looks very sad Christmas tree, but that's where the name originally comes from. These days, the valves are really packed into it. It looks more like a cube, but it's 40, 50, 60 ton piece of steel that is quite costly. And quite complicated because you need to rely on these valves. Back to the value case, or back to why this is a good idea. So we had multiple projects performed now. We just not last weekend, weekend before last weekend, where we installed 2 of them within 24 hours. So very efficient installation.
For parking, that is.
For parking. And the trick here is you run down with the BOP, you pick up the Christmas tree, you skid over and place it on that CAN parking. You have a very reliable parking. That piece of kit is, Peter, help me out. What's a typical Christmas tree, the cost of typical Christmas tree?
Cost of it can be anything really, but say maybe 10 million US easily. Yep.
Yes. So that's a piece of kit you don't want to just put on a seabed and hope that it doesn't get damaged. So you can park it on a wellhead and lock it in. ROV can do the testing that is required. The well is being worked over, or a sidetrack is being drilled. And then once that's finished, you can just skid over again, pick it up, and place it back. The saved rig time by not pulling the BOP with the Christmas tree to surface, the maintenance of the BOP, the maintenance of the Christmas tree, that again amounts to 5 to 6 rig days. So 50 to 60 million saved. It's a very, very good value case. Makes things also much safer because, as I said, the BOP is 250 ton. Christmas tree is 40, 50 tons. There are lighter ones, there are heavier ones, but all that needs to be handled on the rig where people are involved. Lifting heavy things is always a hazard. So it also improves the what we call operational window. So running BOP requires quite good weather there is a lower threshold on the maximum wave height that you have than doing subsea operations. So thinking of doing these operations in wintertime, it can also save waiting on weather because the operational window is less weather sensitive.
No, I think the conclusion there is a lot of opportunities to leverage the technology, but I think Wolfgang put it very straight here earlier, where why is this a better technology than the others? It's really around saving rig time, and by that minimizing the environmental footprint, And lastly, but maybe not less important, removing a lot of risks, operational and safety.
And that brings us to the next episode where we're going to talk about risk management and with the installation of this technology.
We're going to talk about how makes a successful installation.
Exactly.
Yes.
So thank you very much for coming, Wolfgang. It's very interesting.
Yeah, no, I could talk for hours, but
absolutely.
Hope I haven't
Wolfgang was
confused
about
with
to take off there, so.
Oh, very good. Thank you so much.
That's great.